Hello children, welcome back. Now I am dealing with 8th class, first chapter, rational numbers. So in this, what are we going to do? This is 8th class, rational numbers. So before going to do this, let us have a talk about problem. He who hesitates is lost. What do you mean by this, children? Every one of us will do the things according to our planning. But sometimes it happens so that we plan for the things, but afterwards we feel that I don't know whether I can do it, whether I can get all the resources that I require, or whether I can, whether I am having the sufficient knowledge to do this. This kind of questions in our mind will pull us back. Means without continuing that task. Hesitation will make us to reduce our efficiency, children. Remember that. Never hesitate to do the things. One thing you have to think about it, that is it really the one which has to be done? Is it a good thing or a bad thing? That of course you need to find out the difference between good and bad. If you see that yes, it is acceptable. If it is not acceptable, acceptable and not acceptable, not in the sense of your mind's capacity, but in the sense of its goodness and badness. If it is acceptable to the society, and if you have a chance to do it, don't hesitate. You may find initially little bit difficult to do it, but as you proceed, as the days proceed, you have to keep only one thing in the mind: why can't I? When others are able to do, why can't I? Even I can do. Pray God to give you an essential energy, knowledge. Train your mind. Think about that again and again and again. Then definitely you will find a solution. Without doing this kind of work, this kind of planning, this kind of task-taking process, what happens, children? You will lose. The one who hesitates cannot do anything properly. Their mind will not be active. Even if it tries to do it, it cannot do, because you are not motivating your mind. Your mind also should work according to your intention. So your intention should be, I must do it. So if you stop hesitating to do the things, definitely success will be yours, children. Let us come back to our topic. Now, this is about rational numbers between two rational numbers. Rational numbers between two rational numbers. So, let us talk about it, children. Now, rational numbers between two rational numbers, we have two methods in doing this, children. Let us talk about the first method. So, what is the first method? The first method is, you can call it as average method. You can call this name as average method. What is this average method? Suppose you have given numbers 2 and 3 and you wanted to insert a rational number. The question is, insert, suppose 2 rational numbers. 2 rational numbers. This is the question. You have to insert 2 rational numbers between 2 and 3. Actually 2 and 3 are side by side numbers. So between 2 and 3, actually normal 2.5 to 2.1, 2.2, 2.3, like that you will be getting. Decimals you will be getting. Decimals can be converted into PPQ forms. So you can the rational numbers between them. But how? What is this mean method? What is this mean method means? If A comma B are two rational numbers, then the rational number between them is A plus B by 2. This is the formula. If you add the 2 and divide it by 2, you are going to get the rational number between them. So how many rational numbers are asked? Accordingly, you have to, each pair you have to add and divide it by 2. So what you can tell, this is actually mean children. You have done even in 7th class. That what is mean? Sum of the numbers divided by number of numbers. So we are having only 2 rational numbers. So add them and divide it by 2. You are going to get this. So let us see now 2 and 3. So first 2 numbers they are asking now. So first number how will you get? 2 plus 3 by 2. How much children? 2 plus 3 by 2? 5 by 2. So what are you getting here? 2, 5 by 2, 3. You have inserted 1. But we want 2 numbers. So what is the second number? How will you get the second number? Second number you will get either between 2 and 5 by 2 or 5 by 2 and 3. So I am taking 2 plus 5 by 2 by 2. Okay children, 2 numbers are 2 plus 5 by 2. In the earlier case, you have got only single number. There is no fraction here. So 2 plus 3 by 2 you have written. That means the process is A plus B by 2. So A plus B by 2. So here I have got A here, B here. So A plus B by 2. So here what happens children? This is having one rational number and one whole number. So I need to take an LCM here. 2. So here 2 2s are 4. You will be getting 5 by 2. How much you are getting children? 9 by 2 by 2. 9 by 2 by 2 can be written as 9 by 2 into 1 by 2. No children? This 2 means 2 by 1. So A by B, you have got the formula. A by B by C by D is equal to A by B into D by C. This is the formula you have got. So this formula, this if you may not see it, let me write it here. This can be written as A by B into D by C. Reciprocal you are writing for it. So in the same way, 9 by 2 by 2 by 1. It is actually only 2. You have got in the denominator only 2. 2 in the sense what children? It is 2 by 1. If it is 2 by 1, A by B is 9 by 2. C by D is 2 by 1. So I should write A by B as it is. I have written into, division becomes into, reciprocal. See, C by D has become D by C. So 2 by 1 has become 1 by 2. So how much I am getting? 9 by 4. So what am I getting children? 2 rational numbers between 2 and 3 are, what are they? 5 by 2, 9 by 4. So this is the answer. I hope you have followed. This is about mean method. Mean method of finding out the rational numbers between two values. Now, copy this. Now, let us see what is the second method. First method is mean method. It is also called as mean method. What have you done in this? You have added the two numbers and divided by 2. So what many number of terms they are asking? So many numbers can be inserted by using the same formula a plus b by 2. That is mean method, children. After mean method, you are going to talk about the second method. Now let us see what is the second method. The second method, in this second method, see children, you have got two rational numbers 5 by 10 and 9 by 10. And in this, they are asking to insert 100 rational numbers. 100 rational numbers. So, you have got 5 and 9 numerator denominators. First you have to concentrate on denominators. Are they same or not? You see. Here the denominators are same. But when denominators are same, you can see the gap between the numerators. 5 and 9 you have only 4 as the gap. But you need to get 100 rational numbers. How do you get it? So what you need to do? You have to expand this. Like you are stretching the rubber band. Like that you have to expand the gap between 5 and 9 to fix 100. How it has to be expanded? What you have to do is, you take 5 by 10, multiply by 1 by 10 and take 10 by 10, sorry. Take 9 by 10, multiply by 10 by 10. What are you doing in doing so? You are expanding, like you are stretching your rubber band to an extent. This is 50 by 100 and 90 by 100. So even between 50 and 90, how many numbers you can get, children? Between 50 and 90 means you will be getting at the most 49 numbers. So 50 and 90 means you cannot get how many values you want? You want 100 values, but between 50 and 90 you cannot get 100. The gap is not sufficient to get 100. So what you have to do? You have to stretch it much more. How will you do? Take this 50 by 100, multiply by 10 by 10 again, and take this 9 by 100 and multiply by 10 by 10. How much you are getting? 500 by 1000 and 900 by 1000. What did you choose, children? 5 by 10 and 9 by 10. You have divided like this. See, nearly 400 numbers are there between these two. So, you can very easily fix 100 rational numbers. It's so easy. This is what you should understand, children. First, what you have to do? You must see whether the denominators are same. If the denominators are same, observe the numerator. What is the difference between the numerators given? If the numerators numbers are sufficient for the rational numbers insertion, it's okay, directly you can take. But if they are not sufficient, then you have to follow this method. What you need to do? First you multiply with one set of 10 by 10 for both the numbers. In that case, whatever you are getting in the numerator, if that difference is sufficient for you to insert the given number of numbers, it's okay, you can take. Even if that is not inserted, it's just like you are stretching, you wanted to keep a rubber band upon one thing, you have stretched and you tried, it is not fixing. So what you will do, you will stretch it much more bigger so that it can fix. This is what we are doing here. What are we doing? We have to increase the gap again. It means you are stretching the number line. This is what actually we are doing in this process. So by taking 10 by 10 and 10 by 10, we have not got here because we have got the gap between 50 and 90 are at the most, actually 39 you will get. We need 100. So 39 is not sufficient for us. We need much more. That much more, how will you get? Will you stretch it further? How do you stretch it? Just multiplying by 10 by 10. So 50 by 100 into 10 by 10, 90 by 100 into 10 by 10. How much you have got? 500 by 1000, 900 by 1000. You have got numerators 500 and 900. So definitely so many hundreds are there between them. So it is very conveniently you can keep the numbers between them, 100 numbers. So how will you write therefore? 100 numbers means how many you will be writing? The numbers. The required numbers. Required numbers are, what are they? 500 now. So you will be getting 501 by 1000, 502 by 1000, 503 by 1000, like this. 100 means you will be getting 500 and what will be the last one? 599, or you can write as 600. You can write 600 by 1000. When you write this, what are we going to get? You are going to get 100 numbers insertion between them. So it is possible if you do like, you can have still more numbers here, children. The last one will be 900 by 1000. Here 900 means before one is 899 by 1000. Next one is 900. So in between them, you can very easily fix 100 rational numbers. So I hope I am clear, children. So write down this. This is the second method. So remember the two methods that I have taught according to the given problem. Which method is suitable for you? That method you have to follow. If you have only rational numbers with different denominators, go for mean method. If you have same denominators, and you can consider this method. It is easy for you to find out. So both the methods are to be learned, children. Write down. Next. Now, the next one is example 8. Example 8. You have to insert 5 rational numbers between -3 and 0. So if you think the rational numbers between 0 and -3, that is the left side of your number line, 0, -1, -2, -3. So between -3 and 0, you can insert only 2 numbers. But 5 rational numbers he is asking to insert. So let us start the expanding form program. That means what you will do, take -3 and then take -3, multiply by 10 by 10 and take 0, multiply by 10 by 10. What are you getting, children? -30 by 10 and 0. 0 into any number is 0. So between -30 by 10, 5 rational numbers you can easily insert. So 5 rational numbers. Rational numbers are, what you can write? -29 by 10, -28 by 10, -27 by 10, -26 by 10, -25 by 10. See how many? 1, 2, 3, 4, 5. You have done it here. Because left side means you are going like this. So in a descending order we have to go. Right side means in ascending order we will go. Left side of the number line we have to go in descending order. So I hope you have understood, children. Write down. Now, so we are going to talk about exercise 1.2. Exercise 1.2. The first one, represent on the number line. Represent on the number line. The first bit is given as 9/7 and second bit is given as -7/5. I told you when I was talking about this representation of the numbers, children, that when you are taking about the two numbers, rational, either 2 or 1, whenever you are inserting a rational number between upon the number line, first thing what you have to observe, children, you should see whether the given ratio, that is the given fraction, is a proper fraction or improper fraction. Already I have explained. If you see the previous videos, you will understand. Proper fractions lie between 0 and 1. And improper fractions lies according to the mixed fraction. Improper fractions means the fraction which has got numerator more than the denominator. So every improper fraction can be converted into mixed fraction. When you have converted it to mixed fraction, you will be having an integral part and a ratio part. So integral part, whatever you have got for that mixed fraction, between that and the next number, the given ratio will be there. The given rational number will be there. So that very easily you can identify if you have this basic property with you. Once again, what is the basic property? Take the rational number and see whether it is a proper fraction or improper fraction. First thing is that whenever you are representing any rational number on the number line, first thing is observe the given problem. Is it a rational proper fraction? Is it an improper fraction? You should have the knowledge of course, proper fraction, numerator less, denominator more. Improper fraction, numerator more, denominator less. I am going back to your lower classes, children, to have a clear explanation so that those who need it also will understand. Those who already know, please bear with me because this videos I am taking for everybody. That is why I am giving, I am sometimes going back. So here, after knowing that proper fraction and improper fraction, the knowledge is it should be between 0 and 1 if it is a proper fraction. If it is an improper fraction, according to the mixed fraction, you can decide between what numbers it is there. So now, first thing, proper or improper. See children, 9/7, 7/5. How are the children? Numerator is more than denominator. Numerator is more than denominator. That means they are improper fractions. Improper fractions. So I have understood now that they are away from 1. So where they are? So let me take the first one, 9/7. If I take 9/7, convert it into mixed fraction, 7 1s are 7, 2. So what am I getting? 1. It is 1, 2/7. What did I understand? Integral part is 1. Therefore, the number lies between 1 and 2. So I have got a very clear idea that the number lies between 1 and 2. So first let me draw a line. After drawing this line, this is a line that I have drawn. This is 0. Of course, minus 1, it goes on like this. Now between 1 and 2. So I am going to keep 1 here. 2. So before writing 2, see the denominator. Whatever is the denominator, that many parts I have to make. Denominator is 7. So 1, 2, 3, 4, 5, 6. This is 7. So this is 1 and this is 2. 7 equal parts I have done by seeing this. Now what will be this point, children? This is 1 by 7. This is 1 2 by 7. 1 3 by 7. 1 4 by 7. 1 5 by 7. 1 6 by 7. 1 7 by 7. So what I am getting? 1 7 by 7. 1 7 1 the 7. 7 plus 7, 14 by 7. 7 1 the 7 2 the. I have got 2. See, both of them are same. Here, what I need? 1 2 by 7. This is 1 2 by 7. This 1 2 by 7 is how much, children? 7 1 the 7 plus 2, 9 by 7. So you have represented 9 by 7 upon the number line. So easily. So if you know this method, very easily you can represent the number, rational number upon the number line. I hope you have followed, children. Copy this first bit. We will do the second bit. Now, second bit, minus 7 by 5. Means, children, 7. When you take 5, 5 ones are 5, 2. So what you are getting? Minus 1, 2 by 5. Again, when you have got this, I can understand that the number, therefore the number lies between, what are the numbers, children? Minus 1 and minus 2. I have got an idea where the number, given number lies. It is between minus 1 and minus 2. I have got. So again I need to draw a number line. So after drawing the number lines, negative values, the children. So I'll start from here. This is 0, 1, 2, 3. It goes on like this. Now between minus 1 and 2. So I can take this as minus 1. And before talking about the 2, let me see what is the denominator. Denominator is 5. That means between minus 1 and 2, I should divide 5 parts. So this is 1, 2, 3, 4, fifth part. This is minus 2. So what does it become, children? Minus 1, 1 by 2, minus 1 by 5. 5 parts we have done now. Minus 1, 1 by 5, minus 1, 2 by 5, minus 1, 3 by 5, minus 1, 4 by 5. Let me write this a little bit side. Now this is minus 1, 5 by 5. How much, children? 5 and the 5 to 7. Minus 7. Okay. 1 1 by 5. 1 2 by 5. 1 3 by 5. 1 2 by 5. And minus 1 5 by 5. This is. So 1 5 by 5. How much you will be getting, children? Minus 1. 5 by 5 means 5 on the 5. 5 plus 5. 10. Minus 10 by 5. 5 and the 5 to the, you will be getting minus 2. See, both of them are same. So here which number we need to learn? Minus 1, 2 by 5. Where is minus 1, 2 by 5? This is. Minus 1, 2 by 5. That means 5 and the 5 to 7 minus 7 by 5. You have represented minus 7 by 5 upon the number line. So I hope you have followed, children. If it is a mixed fraction, this is how you have to represent. First you need to find out what is proper or improper. Convert improper fraction to mixed fraction. Identify between what integral numbers the number lies, and by seeing the denominator, divide it into so many parts, and after dividing, you can very easily identify the number. Copy this, children. Now, let us see the next one. Second one, represent minus 2 by 13, 5 by 13, minus 9 by 13 on the number line. Again you see, children, in all these cases numerator is less. So all these are proper fractions. Since these are proper fractions, therefore they lie between. See, children, you have got negative as well as positive. So you will write 0 and 1 and 0 and minus 1. Both the sides, because you have got negative as well as positive. So let us draw a number line here. You have got positive and negative, children. Now, what is denominator? Denominator is 13. We know that between 0 and 1 the number lies. But how many parts you have to make? According to the denominator. That means if I take 0 here, between 0 and 1 I need to make 13 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a little bit more I have to draw. 30. So this becomes 1. So what am I getting here, children? 1 by 30, 2 by 30, 3 by 30, 4 by 30, 5 by 30, 6 by 30, 7 by 30, 8 by 30, 9 by 30, 10 by 30, 11 by 30, 12 by 30. This is 13 by 13. 13 by 13 means 1. So these two are same. Now left side also I need to divide 13 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I need a little bit more. 12, 13. So this is minus 1. So minus 1 by 30, minus 2 by 30, minus 3 by 30, minus 4 by 30, minus 5 by 30, minus 6 by 30, minus 7 by 30, minus 8 by 30, minus 9 by 30, minus 10 by 30, minus 11 by 30, minus 12 by 13, minus 13 by 13. This is minus 1. So you can see both of them are same. Now what you need? Let us see the numbers. First minus 2 by 13. So this is minus 2 by 13. Next, this is minus sign for it like this. Okay. Next 5 by 13. This is 5 by 13. Next minus 9 by 13. Minus 9 by 13. See children, how easily you have represented all the three on the same number line. You could do it on the same number line because the denominators are same. If the denominators are different, each one should be drawn in one separate number line. Okay children? Otherwise, in a single line, if they ask you to do, you have to, for each number, you observe what is the denominator, that many parts only you have to do. Suppose you have got 5 by 7. That means what I should understand? 0 to 1 I should divide 7 parts and 5 by 7 I have to keep. So in the same line you are drawing means you have to observe the denominators. If you want to do it in different ones, it's okay. You can very easily do it. So anyway, this is the procedure children. I hope you have understood. Write down. Next. Now, let us see the third part. 5 rational numbers. You have to insert 5 rational numbers. Five rational numbers smaller than 5 by 6. So 5 rational numbers smaller than 5 by 6 means what you can take children? You can talk about the rational numbers are only one is given, so you can write the rational. The rationals are, you can write. What you can write? 4 by 6, 3 by 6, 2 by 6, 1 by 6, 0. How many? 1, 2, 3, 4, 5. You have done? 0 by 6 is 0. So directly you can give this as the answer. Now, fourth one, insert 12 rational numbers. 12 rational numbers between -1 and 2. Between -1 and 2, 12 rational numbers means how many you will be getting children? Just you have an idea between -1 and 2. -1 and 2, 12 rational numbers means 2 and 1 actually in the number line -1, 0, 1, 2. So very less values you will be getting. So you have to expand it. So take -1 and 2 and you convert it as -1 into 10 by 10 and 2 into 10 by 10. So that you will be getting -10 by 10 and 2 by 10. So -10 by 10 and 2 by 10 means very easily you can insert 12 rational numbers. So the required numbers are how many? 12 -9 by 10 -8 by 10 -7 by 10 -6 by 10 -5 by 10 -4 by 10. How many? 1, 2, 3, 4, 5, 6. -3 by 10 -2 by 10 -1 by 10 6, 7, 8, 9, 10 is this. Then 1 by 10, 11, 2 by 10, 12. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 rational numbers you have inserted between them. This is your answer. So write down this children. Now the next one, fourth one, insert a rational number. Fifth one, a rational number they are asking. A rational number means you have to insert a in the sense only one rational number between 2 by a number between 2 by 3 and 3 by 4. So only one rational number. So you can go for average method, that is 3 by 4 by 2. That is, here you have to take LCM 12. 3 4s are 4 2s are 8. 4 3s are 3 3s are 9 by 12 by 2 by 2. That means 17 by 12 by 2. Means I told you 2 by 1. That means 17 by 12 into 1 by 2. So what are you getting? 17 by 12 2s are 24. This is the answer for this problem, children. So write down. Now we will go for sixth problem. Now, what is the sixth problem, children? The sixth problem is insert 10 rational numbers between, sixth one, insert 10 rational numbers between minus 3 by 4 and 5 by 6. So let us, the denominators are not the same, children, 4 and 6. So first we make the denominators as equal and see whether you can represent 10 numbers. So for that, what you have to do? You have to find out LCM of 4 and 6. So 4 and 6, 2 2s are, 2 3s are. So what is LCM? LCM is 12. So minus 3 by 4 into 3 by 3, no? 4 3s are 12. So how much you are getting? Minus 9 by 12. 5 by 6 into 6 2s are 12. So 10 by 12. So minus 9 and 10 means you can very easily get 10 numbers, children. So 10 rational numbers between minus 9 by 12 and 10 by 12 are, what are they? Minus 8 by 12, minus 7 by 12, minus 6 by 12, minus 5 by 12, minus 4 by 12, minus 3 by 12, minus 2 by 12, minus 1 by 12, 0, 1 by 12. See how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the 10 you have got, children. 10 rational numbers you have got between these two given rational numbers. So I hope you have followed, children. This is, with this you can copy, children. So with this first exercise is completed. Please observe it carefully. Again and again you go through the insertion, how to insert rational numbers between them and how the numbers, rational numbers should be represented upon the number line. Very, very important topic, children. Thrice go through the video till you understand it. And again, if you have any doubt, in comment box if you say, I will definitely explain you.